So that's it. And going through it again, just for the sake of certainty, like I said, first terms I always make the connection between this and this, and then this and that. Of course, gamma, beta and gamma for every such term in terms of the symmetrization will always follow each of the terms. And then in the next term, what I try to do is interchange, due to the fact that even though I interchange mu and alpha here, the metric tensor still remains the same. And so that is it, being symmetric. Then plus the same for the second one, nu and delta, beta and eta for the first term. And the next term I interchange. And I'm always switching just the ones on top to avoid any confusions. Then alpha and gamma is what I've got here, minus, again, alpha, delta, beta, eta. I make the interchange again. I've always, if you notice, have maintained the order of the lower indices. Then nu, gamma, of course, will be both common to both terms here. Now, what I'm going to do next will be to evaluate what N1 will be for each and every one of these terms. So we might get something very long, but I believe this will be the easiest way for us to get quickly to the solution we are looking for. First of all, note that N1 has a half. And each and every one of these does have a half, or have 1 over 2 on it. So to keep this simple, I'm going to pull out 1 over 4, so that whatever I write next with the evaluation of this factor, I wouldn't bother about this 1 over 2, neither will I bother about this 1 over 2. So in essence, I'm looking at just this whole thing being multiplied by the chronicle deltas here. For the first term here on this term, what I'm going to do is to try to evaluate where do I have, for instance, I've got here everything, I have a delta here and I have an eta. So I'm going to choose which ones I'm going to be replacing, either the ones on top or the ones below. So I'm going to choose, for instance, to replace the ones below, delta and eta. So for this first one, I have got G, beta, alpha, comma, mu. This will be unchanged. And I have G, mu, nu. That will be unchanged. Then I have G, subscript here, rho delta. So I'm going to write rho. However, my delta this time around is going to become a nu. So I put that to be a nu. Then I have G, again, sigma, eta. Sigma, but instead of eta, I put alpha, plus. So that is just for this part of the term. Okay, looks like I'm about to forget something. Or maybe I should just very quickly, to make things easier, as something common to all of them is this chronicle delta 2, which suggests you should change gamma wherever you see it to beta, but on this expression we don't have a gamma. However, we have a beta, which I just erased. The beta I'm going to replace with gamma, so I wouldn't have to bother about that. That is for this one. Now for this one, I'm going to repeat the whole thing plus. Of course, I think beforehand, I guess nothing is going to spoil if I simply call this gamma already, with the belief that I've already evaluated this chronicle delta. So the next thing I'm going to have is comma mu, G again mu nu, which is untouched. But then looking at this expression, G rho, instead of delta this time around, I have an alpha. And then G next, sigma, instead of eta, I have a nu. That is what I've got for this one. Of course, you can see it just looks like I've just made an interchange. But that's the essence of the symmetrization. So these two terms have been obtained from this alone. I don't think, let me not obfuscate things yet. So this is what I'm going to have. I'm going to move on to writing the expressions for this one. So again, coming over here, I'm going to be careful here. So let me just move on. What I've got is to change delta and eta. So the first few factors, or first two factors, this remain unchanged. I have here G mu nu. And so the G mu nu is here, but then I have G rho. Instead of delta, for the rho, oh my God, I think I already made a mistake, so but no problem. Let's move on. So this should have been G beta alpha. That's what it is here. So G rho, instead of delta, remember we are looking at this first one. I put a nu, then G sigma. Instead of eta, I put a beta. Then the one that is common to all of them, which is outside, is gamma alpha. So I'm going to look for wherever there, of course, again, there is no gamma, but we do have an alpha here. So alpha here will be changed to gamma. That's what we have. Now plus, I'm guessing this will be the same for the second one, that alpha again will have to change to gamma, comma mu. This is G mu nu. So very quickly, I'm back here to where I could make the changes. Now for this second term, I have a delta. Now the delta here in the second term becomes a beta. And then G, this is sigma. Again in the second term, eta becomes a nu. That is what I've got here, just to avoid any mistake. So we have just finished with this term here. Now again, minus. So I'm going to deal with the very last time over there. This will be minus. Again, I'm going to have G. Just to avoid any mistakes, for the start, I'm going to write G beta alpha, and then comma mu, G mu nu. Now G, for the first time I have rho. I have a delta here which should be alpha, and that is what I've got. Next, I have a G again with a sigma, and I have an eta which should be beta for the first time here, beta. And of course, there is a common one outside which says a nu should become a gamma. Again, there's no gamma on our expression, but wherever we see a nu, we should change it to gamma. And turns out on the whole expression, nu appears again just once. And so in this case, this becomes a gamma. Now for the second time again, still with a minus G, I'm going to put beta alpha, comma mu, G mu, I'm going to assume or believe that the same thing applies for this, so the nu again is going to change to gamma. But in this case, for the first time I have a rho, and what follows the rho is a delta. And in the second term, the delta should be a beta, for that expression to be non-zero. Then sigma with an eta, the eta there should be what? An alpha. So again, it just looks like what we've got. Now, and that completes it all for that. Wow. Okay, well, let's just hope things get a little better and see if we can. We shall move over to this side of the board so that we wouldn't have it all clogged up down that side. So what we've got here is this. Remember, what we are solving is entirely n. And by the way, I think I have no need for this n1 anymore because, as you can see, it has all been multiplied. The n1 have gone into that expression. So n itself in general is equal to minus the square root of minus g all over 2. And then what I've got here is, this is rho sigma, and that is multiplied by gamma plus. So what have I got here? What I've got here is, carefully if you look at this. In order to avoid mistakes, remember that n1 multiplying this whole thing turned out to be 1 over 4, so I'm going to have a 1 all over 4 here, just to make sure I don't miss this. And then I open such a bracket as that. Here I'm going to make an identification, that, and then over here I'm going to make another identification, this and this. Here I have another one, and then over here I'm going to make another identification, these two. The last one I don't see, but let's see if there's something we can do about that. The last set of expressions, we have this, for instance, following us. Okay, so I'm going to sort of lower. So I'm going to use this to lower beta, and to lower alpha, and this to lower beta. So I'm guessing I'm going to need this. Okay, let me just, for the sake of argument, I hope this doesn't confuse things here. I'm going to lower this, and with this, I'm going to do that. So I'm just going to give this so that to say I wouldn't have to, I don't want to draw that on the next term there. So what's the identification here? You can see that the product of these two metric tensors, nu is common to both of them. This gives us a chronicle delta. So what I've got there is G gamma alpha comma of mu, and I have a chronicle delta following me of mu and rho. And what else is left for us there? We've got some G sigma alpha. I believe that's what we have there. Next, I have plus again. What I've got there is G gamma alpha comma mu. Then again, I should have another chronicle delta. I'm combining these two because of the mu common to them. So this becomes mu sigma. Mu sigma. Moving on, of course, then what follows them is G rho alpha. That's what we've got. And that settles that for that, the first two terms. The next few terms is going to be, here I will have a plus. What have I got? So G beta gamma, comma, mu, and I believe I'm supposed to get a conical delta of mu alpha. Mu rho, sorry, not mu alpha. I think I made a mistake by saying that. So G sigma beta follows, then plus the next term there I've made another. So first of all I've got G beta gamma comma mu, then the conical delta beta gamma comma mu. The conical delta this so is going to be mu sigma. Then I've got with me G rho beta. Okay, now this term here that I've drawn a lot of things there to say. So what I think that would be is minus. I'm going to have here with me G. Now you can see if I were to use this to lower beta. So for the first one I'm going to have G sub sigma. It comes down. The alpha will be lowered by this so that I've got here rho, comma, what I had there originally, which is mu. And then of course it means these two are disappeared, these two are gone. So I've got with me a G, but that would be mu gamma. So that's that. Now the very last term becomes minus. So what am I going to do again? So I'm using this. So well, I might as well just do the drawing all over again. So this is that, and this comes over here. Yeah. That comes over here. So I'm using this expression to lower the beta, which will be a rho. Yeah, so that is minus G rho. The next term that I'm lowering is the alpha, and I'm using this. So it's going to give me a sigma, comma. Of course, I had a comma on that term. This is comma mu. And that is it. What else have I got? I've got left all alone. So these two again are disappeared because I've used them to lower these two indices. So I'm left with G mu gamma. This is G mu gamma. And that's that. I think this is becoming a little... so everything, if you remember, is multiplied by 1/4. So we're going to keep the 1/4 out there for a while. I think we still have a little more simplification to do. Minus G/2. So very quickly, gamma rho sigma. Now plus 1/4. The first term here, so we'll simply just evaluate what we've got. I think I'll do this in 2 steps so that I won't have to write a lot of things over and over again. First of all, I'm going to use this expression to change a mu, which is this one, to rho. And then I'm going to use this metric tensor to lower the alpha. So we're going to have a funny expression. So this is going to be G gamma. But then the alpha here gives me a sigma, comma, instead of a mu, it becomes a rho. Next, plus, I perform another expression. This is another operation. The mu again, I'm going to change to sigma. So, but then before that, I'm going to use this to lower this. So I have a gamma again, but then I'm lowering an alpha, which will become a rho, comma, this mu then becomes a sigma, courtesy of that conical delta. Now this one also I'm going to use to do the same thing. This will then be a plus. Now if you look at this term here, I'm going to use this again to change this mu to rho. But then I'm going to use this metric tensor to lower this. So this is going to be for me G. Instead of beta over there, sigma has been lowered. And then that is gamma over there, comma. Instead of the mu, it becomes a rho. Plus, I have another metric tensor here. The mu here will be changed to a sigma. The beta is lowered, and then it becomes a rho. And the gamma is over there, comma. Instead of the mu, I have a sigma. Then the last two here, we'll definitely have to do something about that. But instead of, to avoid me having to bend my knee here, so I'm going to write this up. I have this should be a minus. Minus, I'm going to be raising. So I'm going to have here with me G. Wow. Yeah, well, we will have no option but to do that. No, actually, I'm not going to do that. I'm not raising any more things because it will ruin things for me. So what I'll simply do is combine these two. These two are the same. Excuse me. This is minus G rho sigma, sigma rho. This is rho sigma. So, and then comma mu, and G mu nu, G mu nu. So first of all, we can see this as simply, even without having to go up anywhere, this is minus 2 of G rho sigma, comma mu, G mu gamma. Close bracket, and that. So remember the 1 over 4 again is for all of them. Again, this is equal to minus the square root of minus G all over 2. And then I have here for the first one, gamma rho sigma plus, again 1 over 4 multiplied. Looking at these first two terms here, these two terms are just not the same. They're not the same because if you look at them, well, here then we have, I have a trick that I'm going to play. I'm going to use a metric tensor to lower this one. And if I'm going to do that, let me do something like this. This is G, let me say mu, for instance, gamma, and then I'm going to have mu here, multiplying sigma, comma rho. Take a look at this term. It's very much the same as this. Because with this mu, I can raise the mu all over again and then I'm back here. Right? So I'm going to do the same with this one. This again is plus another G. Well, I can use the same dummy index again. Lowering again the same gamma. This is going to be G sigma. Instead of gamma over there, it becomes a mu, comma, rho, all over again. So, no, sorry please, so I think I'm making a mistake. This should be gamma. So if I lower this, so I think I'm repeating myself for the first time. If I lower this for instance will become mu rho, but then here, comma, I'm making the same mistake again. Yeah, mu rho, comma, sigma. Mu rho, comma, sigma, that's what it should be. Mu rho, comma, sigma. That is the second term. Now the fourth term is going to be, again, I want to lower this. Permit me to use mu again as my contracting index or the dummy index. So this is going to be plus another G mu. I'm guessing what I've got on top over there is still gamma. So this down is sigma mu, comma. What have I got there? Rho. And I think that is it for that. The next time again says plus G another mu gamma. But then down here I have rho mu, comma, sigma. Minus 2 here, G rho, sigma, comma, mu. Then I have G mu, gamma. Again, so you see one of the reasons why I decided to use mu as my dummy index is because I have mu here too. And miraculously, you can see I have G mu nu, G mu nu, G mu nu, and G mu nu. However, we can see right away that this term over here and this term over here are the same. I can label them both as 1, 1. And this term here and this one here are also the same. I can label them both as 2, 2. Right? They're all the same. G rho, mu, mu rho, all the same. So this is the same thing as I think it's time for me to wipe this piece. Here as minus 1 again, square root of minus G, gamma, plus 1 all over 4. So I have here 2 because I said they are the same. So it occurred twice for this one. Mu sigma, comma, rho. And plus the other one to occur twice. That is 2G mu, gamma, G mu rho, comma, sigma. And then minus twice of this. Okay, let me write this factor first. Gamma mu. That is gamma mu. Then I'm left with G rho sigma, comma, mu. And that is it. I have 2, 2, 2 all over the place. So this is minus that all over 2. Gamma rho sigma gamma plus. So I have 1 all over 2 here. And then common to them is G mu that, and then I have here comma rho, G again mu rho, comma, sigma, minus G rho sigma, comma, mu. And that is it. Yeah, so the 2's cancel, and then I pull out what is common G mu nu for all of them. And of course, we can see already that this is the same thing as that rho sigma or sigma rho. Either way, the same with that. So in the bracket, we're left with twice of that. Twice of that divided by this 2. So this implies that n, which by the way is the same thing as d. So I think I should put this in a box, and there shouldn't be a thing bothering it at all. So we have just shown, as you can see, I have to write that all over again. So minus 1 all over 2, okay, well, this is n equal to minus g all over 2 times twice of that rho sigma. This is minus this gamma rho sigma. If you remember what our n was, this is n. And this is what we intend to show. So thank you so much for being with me on this particular episode, and hopefully we shall meet again in the next one.